Hi everyone, we are on to chapter 7, and this will be the last unit that we are formally covering. So we're starting off with section 7.1 called Cartesian vectors. So last unit we talked about vectors in what we call their geometric form, and a vector was defined by a magnitude and a direction only. Okay, so this unit, a vector will be given in terms of its components, a comma b, so that's x comma y. Okay, so any vector, right, you can figure out its component in the x direction, its component in the y direction. So why do we do this? Or it can also be an a, b, comma, c for 3D. Okay, so but why? So it is easier to determine results when combining multiple vectors, especially in 3 dimensions. Okay, it allows a user to program a computer to perform operations with vectors. So for example, if you're into like an AutoCAD program or any kind of geometry program, you can click on 2 lines and the computer will tell you the angle between those lines, right? So we're looking at how does the computer figure out that angle, what operation is performing. So I'm going to show you in this unit how to compute angles between vectors just by doing some simple arithmetic. And like I said, it's much easier to perform operations in 3 dimensions. So I'm just asking you guys to watch this clip, and this is the application of vectors in video games. Okay, it's really interesting. And if you see any others cool videos, post them in the discussion area. And I just have another useful application. Okay, and this is like 3D design, right? So when you're building a 3D, so I have a shed here. There's a lot of difficult angles to figure out where the beams meet, right? So you have like these beams meet these beams here, right? And then you have like these angles, these angles, these angles here, right? So when you're in 3D, it's a lot easier to figure out angles just by putting points in ordered pairs. So for example, we would start here, and let's get back to it. Okay, you'd pick one point as your like 0, 0, 0 spot, and then each corner where you want to figure out an angle. So I want to figure out like this angle right here, right? So what you do there is you would create a vector from here to here, right, using ordered pairs, a vector from here to here, and then you perform an operation to figure out the angle between them. All right, enough of that. So a Cartesian vector is a vector whose endpoints are defined by ordered pairs. Okay, and a position vector is a special type of Cartesian vector whose tail is at the origin and tip is at some point P, A, B. So a position vector is given as square bracket A comma B if it's in 3D comma C. Okay, and square brackets are used to represent a vector with tail at the origin and tip at the point AB. Okay, round brackets simply indicate a point. So all Cartesian vectors can be transformed to position vectors by simply subtracting the coordinates, tip minus tail. So for example, point B has the coordinates 7, 7, and point A has the coordinates 3, 2. So if I want to create a position vector, what I want to do is I want to take this vector and I want to shift it to the origin, right? So what do you do to shift it to the origin? You're going to move it down 2, so you're going to subtract 2 from the y coordinates, and then we want to shift it left 3, so you're going to subtract 3 from the x coordinates, right? So what we do here is we're going to subtract 2 and subtract 3, and we're going to do it. So all you do is you just do b minus a to get the tip vector. Okay, so it's going to be 7 comma 7 minus 3 comma 2, and that means that b will be at 4 comma 5. So this would be the position vector because the origin is out here. So we're going to go 0, 0, and then 4, 5, 4, 1, 2, 3, 4, 5. And there we go. So this purple vector I just drew is the exact same as the vector AB. It's the same length and it points exactly in the same direction. All right. Unit vectors are vectors of length 1. So common unit vectors are vector I, which goes along the x-axis, right? It's 1 unit long, and vector j, which goes along the y-axis. Okay, and these are the building blocks of Cartesian vectors and are often used to prove properties. Any position vector can be written as a linear combination of I and j. Okay, so for example, 2, 5 is the same as 2 times vector I plus 3 times vector j. And you often write a hat over top like that to indicate unit vectors. Okay, good. Properties. So when we're adding two vectors, we simply add the x coordinates. So it'll be a1 plus b1, comma, a2 plus b2. Okay, and to multiply a vector by a scalar is just a number. Okay, you just multiply each coordinate. So it would be k times a1, k times a2. Okay, and the a1 is your x, your a2 is your y, right? Okay, same thing here. Okay, and now the magnitude of a vector, okay, is just the Pythagorean theorem, right? So if you think about it, you have a vector that goes to this point right here. Okay, so this distance here is a1 and this vertical distance is a2. So the length of the vector, or what we call the magnitude, is equal to a1 squared plus a2 squared square rooted. Okay, and definition, collinear vectors just means that the vectors are parallel. So one vector is a multiple of the other vector. All right, so we just got an example here. So given the points A and B, determine the position vector u, which is equal to AB. So what we do here is we're going to get the coordinates of B minus the coordinates of A. And we equal, now that when we subtract them, we're going to get our position vector, 3 minus 1, which is 2, and 4 minus 5 is negative 1. Okay, so again, if you plot the points 1, 5, and 3, 4 and connect them, and then plot the point 2, negative 1 and draw from the origin to that point, they will be the exact same vector. Okay, now 4u is going to equal 4 times 2 is 8, 4 times negative 1 is negative 4. The magnitude of u is going to equal the square root of 2 squared plus negative 1 squared, which is root 5. Okay, and express u as a linear combination of I and j. U is equal to 2i minus j. There's our hats, should put our arrows. And determine a vector that is collinear with u. Okay, so we actually did that in B, right? You just pick any number and multiply it by. So we could pick, so for example, we could pick 2, negative 2, it doesn't matter. Any number times that, so we'll just use that, 8, negative 4. Okay, now write the vector 120 kilometers north 30 degrees east as a Cartesian vector. Okay, so we'll draw it out. And we're going to go north and then 30 degrees to the east. So we have 30 here. And we want to figure out the x and y coordinate. So we want to figure out its x and its y coordinate. Okay, and that's 120 there. All right, so there's our x, there's our y. So we just use trigonometry, just basic SOHCAHTOA. So we have that sine 30 is equal to opposite over hypotenuse. And we all know that the sine of 30 degrees is 0.5. So we're going to have 120 times 0.5, which is 60. And then we have cos of 30 is equal to y over 120. And cos of 30 is root 3 over 2. So we can keep it like that. Or we can convert it to its decimal. And we get 60 root 3 is equal to y. So that means that the position vector 60 and 60 root 3, okay, is the same as this Cartesian vector. Or you can write it as, you can factor out as 60 and you can write 1 root 3. Either or, it doesn't matter. And there is your work for today.